Hello, everybody. Good afternoon. My name is Rémi Demerlet. I'm working at Semtech. I'm chairman of the Smart Utilities Work Group in the LoRa Alliance. And today, our speaker will have important duty to keep you awake after lunch, but also for one good reason, one time in your life, you can today get high expertise and experience in the water business. Somebody who has a long road behind him, who knows well how the technology can change things for good. You have seen on screen how important are the water damage. It costs $2.5 million per year in US because of pipe breaks, water leaks, and so on. So we cannot do everything in once, but at last we have the technology which has power to change things. So today it's my pleasure to welcome Rich Sanders from Zenner and board member to speak to you about the technology advantages of LoRaWAN for water. Please, Rich, come.
Thank you. Welcome, everybody. I'm going to try and keep you awake since he was right. You just ate lunch. And I promise I'm going to try and be entertaining during this presentation. But we're also going to learn about some very interesting facts and why you should be interested in LoRaWAN. And not only just LoRaWAN, but LoRaWAN certified interoperable products. Because I think it's an industry-changing or globally changing technology that will open up a lot of things. So in starting, let me get my clicker over here. They tell me it's right here. And look at that, it's like magic. So we're going to talk about why AMI in the utility industry makes sense. You know, the utility industry supplies those things we need to live: water, gas, and electric. How big is the market? For those of you who are in this room and are adapters or looking at places to develop products for, the utility industry represents a huge opportunity. So we'll talk a little bit about how big the market is, specifically in the US. LoRaWAN, key benefits to utilities. LoRaWAN, why it is a leap in technology. And this is something I find as I go across the utility industry. I spend most of my time on the road. 80% of my life is visiting customers, doing sessions at trade shows for the utility industry, and I'm always amazed at how little they know about the new LoRaWAN technology. So it's our duty to educate everybody on where that's taking us. How it compares to other technologies in the market, that's important as well. I can tell you that Zenner is not new in this technology business. We didn't just come in and say, hey, LoRaWAN's a way for us to get in the market. We've been in this market for 120 years. This is not new to us. LoRa represents an opportunity for us to provide better services globally to all our customers. And that's what I'm up here to explain. And we're going to talk about that through actual applications of the technology, both in other technology cases and with using LoRaWAN. So amazing stuff we're going to talk about up here. There we go. So let's talk about what drives somebody to a decision. Well, you know, human beings are unique because most of the time, I would say 95% of the time, we make our decisions completely based on emotion. And then we defend them with logic. That's how we make decisions. And if you don't believe that, think about your own life. When you buy a car, you go out to shop for a dress for your wife for an event. I mean, all of that is done emotionally and how much you spend on something. So it's very important. What's really interesting is in our industry, technology has a return on investment. And we've done thousands of systems. And I can tell you that the average ROI on a system for water or gas or electric is between 2.5 and 4 years. Now, and this happens to be a customer, and we have a tool we use to forecast ROI based on a pilot program. But what's more important is this happens to be a customer that had a system put in, and they're in a ski resort, and so for literally 7, 8 months of the year, they couldn't read their meters. They couldn't see any leaks in their main pipes. So what happened with the system, because it was a system that could read their meters daily, tell them where the leaks were, they were able to save enough money over one winter from broken pipes, knowing where they were and fixing them, that they paid for the system in a year. So keep that in mind. And how many people here know what net present value is? Net present value? See, not everybody does. So I always mention that. Net present value, everybody knows what ROI is. That's the time it takes you to get your money back you invested in the system. Net present value is the life of the system, in this case, anywhere from 15 to 20 years, and the free cash you get from that system after it's paid off. So for a community, it means more money into the chest so they can do their operations. So it's actually generating free cash for the community. So why should utilities do these systems? Because it has a ROI and net present value. That's the main reasons. Size of the market, well, it's huge in the US. I mean, we're talking about electric, gas, and water. I mean, there are 50,000 different entities that deliver water to people across the US. They're big, they're small, they're medium-sized, but literally 50,000. So there's many different entities that supply water, which we need to provide comfort and life to our people here. Gas, not so many. You know, a lot of them are bigger gas utilities. Same with electric, a lot of bigger gas utilities. Large customer base, but the number is smaller when it comes to the entities you would have to deal with. So it's a huge market. I encourage everybody to look at that. By the way, only about 20% of this market has ever bothered to really automate. 80% of the market is still raw and ready to do automation. So now let's talk about key benefits. For me, it's very simple. LoRa is an open protocol. And I've been, you know, you can tell that I'm a little bit older than most people in this room. I've been around for 2 changing open technologies in 2 different industries. One was the computer industry. I was in the computer industry really when they first started. So, and it was all proprietary. And then it became open with the PCs and all the other things that we had. Completely changed. By the way, IBM fought that. IBM was brought to their knees. They controlled 80% of the world market in an open protocol that everybody else wanted. They fought and they lost. And so we are here where we are today, where computers are more open. They're open to everybody. Same in the PLC industry. Used to be when you bought a logic controller and you automated your factory, that's the only logic controller you used because the others wouldn't talk to each other. And it became more expensive for people to do manufacturing because those PLCs wouldn't talk to each other and you were locked in, so your prices were higher, your service wasn't as good as it should be. And then along came a company, I have to say I worked for them, and said, let's do an open protocol. And we opened that protocol up, and now PLCs today, you can get off the shelf, and they cost you probably 5% of what they used to cost you. So open technology reduces the cost to the end user and doesn't lock them into poor customer service. So it's really important everybody understands open protocols are industry-changing trends. And that's what the LoRaWAN Alliance does. Long-range communication, well, that gets a little confusing because what does that really mean? What do we do different that gives you longer range communication? And we're going to talk about that a little later in the presentation, but it's really important because it's unique. What's done here is very unique in the radio business. Although line of sight, it's hub and spoke. So unlike all the other systems out there that communicate line of sight, you know, line of sight's not new. We've been doing it since we were setting fires on hilltops to let somebody know the enemy's coming, right? If you could see it, if it was a foggy day, you were in trouble, the enemy showed up and you weren't aware of it. Well, with hub and spoke, what's really nice about that is you can communicate to any collector in the system. No other line of sight system does that that's on the market today, which makes it unique, and we really love that feature because you build in automatic redundancy into the system. And we'll tell you the benefits of that a little later. Much lower cost compared to proprietary systems. So you're not locked into one vendor. We just talked about that. When you're locked into one vendor, and you have no other choice because you can't strand what you already spent, prices tend to go up and you're held hostage. So we like the open protocol and the ability for customers to be able to buy even our competitors' products, because then we're all competing on a level playing field, and we like that. Utility can control within one infrastructure all its needs, as thousands of different devices are purchased and provisioned for their use through this LoRa Alliance. That's what's so important about this LoRa Alliance as well. There are all you adapters out there. You're going to be bringing products in that go on the shelf, and they can pull them off and enhance the automation in the city without ever putting in a different infrastructure. It's a wonderful thing for them. Infrastructure can be owned or purchased as network as a service. We have a number of network as a service providers here, and they provide a valuable service because not every city wants to own their infrastructure. So keep that in mind as well, and we'll talk a little more about that. So what does distance mean? Well, you know, we have a lot of different technologies, and again, being old, I've watched all these technologies come into the market and all the great promises they made. You know, I watched Zigbee was going to be a standard, and then it ended up being short distance and only could go from the electric meter inside the house was the main use. And the industry really required something else. Then FSK, which is what's standard in the industry today that we use, FSK, frequency shift keying. Everybody here understand that term? Just very simple, frequency shift keying. It's like AM, FM, right? And that's how you get your reception. You know, FM's a little better than AM. But then you have NB-IoT, which is, or cellular, really, which really has a limit on how far they can go. I mean, you're talking about a 6-mile range before you switch towers, and you're always losing your signal. And then along comes LoRa. And I got to tell you, I didn't believe it when I first heard it. When we first started working with LoRa 5, 6 years ago, I said, oh, yeah, all that, you're going to get 10 miles. No, that's not going to happen. And sure enough, as we started testing it, and by the way, we started testing it in very difficult situations. I'm one of those prove it to me kind of guys. So my research and development guys, some of them are sitting right here, I was very clear to them that we need to make sure we work in the worst situations, because everybody can work in easy situations. And so we began to test it. Our first tests were literally from my headquarters in North Dallas all the way to the DFW airport, which is about 15 miles, with all that air traffic out there, communicates perfectly. Perfectly at 15 miles. Now, Texas is sort of flat. That's why we get all that bad weather coming through there, because we're flat and there's nothing there to stop it. But I got to tell you, it's amazing that we could go that far, that kind of interference at the airport, and it's crystal clear and communicates perfectly. So LoRa gives you the ability to cover more area with less infrastructure and more dependability on getting your information in. So this is what we call the link benefit. Now my engineer down here could probably explain it better. Link budget is basically how clear your messages is at certain conditions, whether you're inside a vault, outside a vault. And basically what this chart shows is that FSK, right, communicates much poorer than LoRa does. LoRa is much better at getting messages through under the same exact conditions. How many people here know what link budget is? Anybody? Just a few? Oh, not a lot? Oh. Perfect. So link budget's very important. So let's talk about noise level. This is the thing I didn't quite understand until they explained it to me. They had to draw me pictures and stuff, and I got to understand it. So what makes LoRa really interesting, it travels below the noise level. There's a lot of traffic, so if you were able to look straight ahead, you'd see all sorts, look like the Matrix with all the data floating around the air. And that's what it would look like. Well, what LoRa does is gets below that matrix so that the distance goes further without colliding with the other data, because when it collides with the other data, it gets corrupted. That's what causes the greater distances that we can travel. We're short bursts of information, so it's chirp technology. Everybody's heard that term, chirp? Yes? And so that gives us the ability to send smaller message, much greater distances. And by the way, about 75% of every device that's used out there can use a small message. So LoRaWAN will fit about 75% of the global market where it comes to devices moving information. So when we look at the different technologies, you know, here we got narrowband. By the way, narrowband is licensed frequency. And that's why it's narrow. When you license a frequency, you got very narrow bandwidth, and that spikes very high into the noise level because they're normally 1 and 2 watt radios. So you're spiking way into the noise level, and you get a lot of interference. Mesh, which is GFSK, is down a little bit because you're not traveling as great a distance. You're hopping from one point to another. So you get less noise interference, less error correction. And then, of course, the LoRa, which is below the noise level. Just a little chart to give you, so everybody knows the Shannon capacity boundary is basically the perfect distance and a perfect size message. That's what you're going to get. Doesn't get better than that boundary. At least we haven't found that yet. So that's what the perfect message is. And you'll see that FSK and GFSK was further down the chart. Not only the size of the message, you know, you're sending much bigger messages, but you don't go as far. And then with LoRaWAN, obviously you're traveling much further. And you're very close to the Shannon capacity boundary. Everybody get that chart? We're good? Don't fall asleep on me. It's going to get interesting. Okay, and here's again, this is just saying, again, one of the wonderful things about LoRa is the ability to communicate lots of different devices over the network. So once a network is in, a city doesn't have to have a network for their pump stations, and we'll talk about utilities. Water utility has SCADA for their pump stations, for their tanks, they got something else, for their sewage department, they got something else, and they got all these networks that they have in their system. And with LoRa, they only need one. So not only does the cost come down, but the confusion comes down because now you can run everything through one database and give them one customer-facing portal that takes the information and uses it together. Today, they have to take everything that comes out of their pump stations, and if they want to compare it to everything they used in the system, they got to bring all that data over to another system and do all that. So with LoRaWAN, the vision is to make our customers seamless across all their needs in the marketplace. And again, having automatic redundancy built in with towers is wonderful because we have bad weather all over our country here in the United States and other parts of the world. So if a tower goes down, you don't want to be without that information. So having redundancy built into any system is extremely important, extremely important. Oh, this is just a simple diagram that explains the devices reporting into the towers. And of course, you go to the LoRaWAN backend server, our joint server, and then you go into either a third party, which could be somebody who's on the system that has nothing to do with the utility. Could be somebody for our networks as a service people. They take a lot of information, tracking material crossing the country, and that will go to the right, through their LNS server and to the right customer and customer-facing portal. So it's really unique technology. No one else does that in the world. And then, of course, you put it on the dashboards or data portals that the customers see. Now, this is really neat. So there's some confusion as well with our customer base. What is LoRa versus LoRaWAN? Well, as you can see here, LoRaWAN is the physical layer. That's the silicon. Where's my friends at Semtech and ST Micro? Are they in here? No. Okay, well, Semtech, ST Micro make the chips that have the modulation scheme that belongs in the physical lower layer when you're developing a product. So on the left, you have product. On the right, you have your server. And then on top of that, the LoRaWAN regional parameters, right, that help you wherever you are. Like if you're in Europe, you're a little different. You're in the United States, you're a little different, right? And then on top of that, you have the link layer, and that link layer is what ties you to the LNS server it's going to. And then on top of that goes your application layer. What do you do specifically? So for us, when we're doing a meter, right, we give them that meter information. If it's tank levels, they get tank level information. So it's really easy. The LoRa Alliance gives you that ability to do that. They don't charge you a royalty. They don't charge you a fee as an adapter or a developer. You get that and you develop your product, go through the certification program, make sure you're interoperable, and what you have is a wonderful product that you now can sell to everybody across the world who's near a LoRa system. So really important. And on the LNS side, for us and other people that are doing the LNS portion, we have our LoRaWAN back-end layers, our LoRaWAN link layer, and of course, our customer-facing application layers for our servers. So we provide those server networks. We have Zenner as a company, has them a lot of places in the world. We have those servers. So it's very important for us to do that. We love the way the LoRa Alliance works and how they support this kind of technology. So let's talk about, we talked about ROI. So how many people are here familiar with the water industry or the utility industry? Anybody? Okay, well, let me tell you, water is really interesting. So believe it or not, in the United States, 35% of the water we treat and send down our pipelines are gone, never gets billed. It's horrible waste. And we'll talk a little bit about where all that waste comes from. And globally, it's worse. Globally, it's worse. Now, you'll find utilities in the industry, they'll tell you that, oh no, we meet our state mandate. We only have 8% water loss. And then when you ask them, how do you track your water? What do you do with your parks? What do you do with your fire department? How do you track all that? We look at our water loss and then we tie our number into that. Well, then you're really just lying to yourself. They don't know what their water losses really are, and it's important that they do, and we're going to see why that's important in a little bit here. So let's talk about integral data. So what happens with a system is you get data that a computer, which, there's some pretty smart computers out there, that can analyze all that data for you, so when you come in during the day, you're not waiting for something to happen and then go fix it. You're looking at a system that can tell you exactly where all your issues are. So what you do with a system is you can curb water losses by a lot, detect leaks at customer locations, identify theft of service, settle usage disputes, monitor and enforce conservation, right-size your meters, perform load studies, eliminate off-cycle reads, deliver detailed. There's a list of things that go way beyond this list that data gives you the ability to do that you never had the ability to do before as a utility. 4% of all utility assets are stolen every year in the US, just as a number. And 4% is a huge number. It's not small. And I'll give you some other examples of theft. We installed a system at a little town called Wink, Texas, in West Texas. They've had a customer there for 3 years who kept complaining, I'm one guy, I don't use this much water, impossible. And they used to go out there and they'd pull his water meter, they'd send it out to be tested by an independent source, test perfect, they come back, put it in the ground, they charge him for it. Did that 3 times over that couple years. We put a system in, we noticed immediately, day one, all his water usage is between 8 at night and 4 in the morning. That's when he's working. Sent the constable out there, and sure enough, his neighbor was running a hose over to his outside spigot and filling tanks all day. Right? So he was performing some sort of illegal activity, right? Which now, obviously, he got caught doing. And of course, the utility apologized to the customer. Now, again, that's one incident. We find people stealing. There are all sorts of engineering feats that happen around a water meter to steal their water. That's all I can tell you. Seen some really ingenious stuff going on. So theft's a big one. Settling usage disputes, being able to, customer calls up and says, I can't use that much water, and you find out, you immediately call up his information, you say, hey, in these 2 specific days, you used all this water, 5,000 gallons of water. Impossible, I couldn't have used 5,000 gallons of water. You quickly call up a map, Google map, and you can see that the house has a pool. Was there anything you did with your pool? The guy goes, oh yeah, re-marsh-sided it. He goes, but the pool's not that big. It can't take 5,000 gallons. And of course it does. So he paid his bill and it went on. So there's a lot of customer service features, a lot of ways to catch theft, preserve your assets, and cut your water loss significantly. And I'm sorry I don't have more time to talk about it, but I'm only limited to 40 minutes. I told them I needed 2 hours. They wouldn't give it to me. So let's talk about the electric data that's transmitted. So on the electric side, package delivers include kilowatts delivered, kilowatt kVAR, kVAR hours, kVAR, volts and amps, lots of information that go into the electric. What's more important about the electric side is if you do it correctly, right, you can find all your line losses. How many people think that every kilowatt that's generated at a plant makes it to the end? Does anybody here believe that? It's not. The best combined cycle plant in the world is about 72% efficient on energy in versus energy out, and by the time it gets to the end user, it's about 51%. Not much different, by the way, than an internal combustion engine on efficiency. So when it comes to electric cars and cutting carbon profile, I don't really buy into that, being I know that industry really well. So there's lots of data you can get on the electric side in automating the electric utilities, helping them preserve their line losses. Aggregation is important. We talked this morning, somebody mentioned the amount of water you lose through mainline leaks, or I think it was one of the slides up here. There are more than 800 mainline leaks discovered every day in the United States. And there are literally more than that that go undiscovered. Think about that. Now I'm going to give you another statistic, right? 24% of all the electricity generated in the United States powers the water and sewer industry in this country. Think about the massive coast-to-coast underground pipes we have that are all pressurized by compressors and stuff. And think about when you have a leak, how often those compressors have to run to keep that pressure up in that pipe to move the water. And what happens is it waits till it gets big enough where the pipe breaks. Then it comes to the surface and they find it. Tell you a little story. Had a system that we put in up in Silverthorne, Colorado. They had a little gated community, beautiful gated community, been there 6 years. They built it. And there's I'm from New York originally, I apologize. We call them cricks. So there was a little creek running through this, and a lot of people bought property on the creek, so they backed up to the water. We then started to aggregate the system. So what we do when we say aggregate, we put a feed meter on what fed into something, and then we measure it against what was sold in that 24-hour period, timestamp it, and then we know we have a major leak. And then you can deploy acoustic leak detection, which, by the way, is only about 50% accurate because their underground conditions vary too much to know how far apart to place them to get accuracy. So what was really nice is we found the leak, we fixed it. Now this community was 1.5 miles away from the leak, and that fed that creek. Think about that. For 6 years, they were flowing water. And think about the waste of clean water. So aggregating, not only in the water industry, but in the power industry. People tap lines all the time. I did a project in Pakistan, and you'd be surprised that people would climb up those poles and tap the hot lines. And we were able to aggregate and start catching people as they tap lines. So it's really important what you can do with a system like LoRaWAN, because you can measure everything and then compare it. Again, this is just line of sight versus LoRa communicating to more than one tower versus line of sight, can't go through mountains, can't go through. Remember, LoRa does a much better job moving through rough terrain. And I'm going to show you an amazing situation here in just a few minutes. Mesh versus LoRaWAN. Mesh is unique only because it communicates from device to device, so it can go around big obstacles. Data costs. Now, this is one of the things that utilities are concerned about. Data costs. You know, your data costs can vary by provider. Just be aware of that. We did a survey looking at different data costs from either hosted or network as a service providers. So it varies greatly. It can vary from $1 to $2.25 if you own the system and somebody is hosting your data, to cellular, which can be $6 to $9.60. Cellular gets very expensive for data. Network as a service, obviously anywhere from 280 to 550, depending on the network provider and what they're providing for you. So network has, all the different providers have different schemes to, and pricing structures to bring your data to you. This happens to be a LoRaWAN network that we're going to be doing up on Lake, Big Lake. Yeah, I think it's Lake Michigan, to be honest. And so this is the kind of information that you have for a system that you're going to be putting in from an economic standpoint. 9 gateways to cover that territory, and a lot of it's because of different elevations. 124 cellular units. And this is one of the things I want to talk about. What's wonderful about LoRaWAN is you can work with other technologies. So in some cases, when we look at something, we say, well, for those 124 meters, it's easier for us to do cellular. And yes, it's a little more cost, but the majority of the system is LoRaWAN, which is low cost for data. And that's the kind of costs that go into doing a system. And the annual costs are typically annual data costs for the whole system is going to be about $7,000 versus $35,000 per year at $6, which would be your cellular costs. So there's a huge difference between using LoRaWAN RF and cellular just from a cost standpoint. Everybody get the point of that? Yes? Basically a cost. When you look at return on investment, when you know, LoRa provides you a much better return on investment because of data costs, the low data costs versus cellular. Software is really important. There's typically 3 pieces of software: the AMI data management, the network manager, the customer portal. And those are all important. I'm going to speed it up here because I'm running out of time. Hosting of data is low cost. Redundant locations, very important if you'd have redundant locations. And of course, they have 24-hour services so you have access to it. So this is a very interesting video. So pay attention to it. It's got some shocking information in it. And I'm very passionate about this. This is one we created, and that is being used by a lot of other large entities around the world, including the World Bank. Can I start this from here? There we go. Okay, so how many people here knew that only 0.5% of the total Earth's content is water? Just happens to all be on the surface. Not many people. Amazing, isn't it? I'm going to give you some other amazing. By the way, I'm just going to give you one other example of greatness here, how great LoRa is. This is Lake Arrowhead, California. How many people have been listening to the news and knew they got all that darn snow? They got pummeled with all sorts of snow up there. And that's at the top of a mountain near LA, and they literally had 15 feet of snow. And I have to tell you what was amazing to us, and we have some LoRa units mixed in with some other stuff up there, a number of LoRa units. We said, let's see how well they do against other technology. Look at this mess. And then look at the distances we were getting. They were 100% of the LoRa units were still communicating up to 3 miles in mountainous, heavy forested, 12 feet of snow. Tragedy. I can promise you there isn't another line of sight system out there that can do that. It's amazing. And by the way, we only use half-watt radios in our equipment. So it's amazing that that kind of distance happens. So I'm telling you, LoRa is not, just a lot of talk. It physically works in the applications we are putting it around the world. By the way, we have multitudes of millions of LoRa units out in the world. But I can tell you, we're tough. We're experimenting with it in some really rough environments, and it's really performing exceptionally well. So one other thing, how many people here, I'm gonna scare you all a little bit. Literally by 2035, 4 out of 10 people on this earth won't have enough water to exist comfortably. I want you to think about that. By the way, when South Africa filled the reservoir, they cheated. They drilled deeper in the earth than they should have to get water, and that's it. When they're out, they're done. There'll be a desert in South Africa. Here's another one that is worth talking about. In the last 25 years, right, population has increased on this planet by 36%. You saw those numbers. And by the way, that trend's not changing, right? You saw it by 2050, we're going to have 9 billion people on this earth. And in the last 25 years, right, our water on the surface of the earth, our ability to have water has decreased by 26%. Now, everybody who thinks that the weather pattern changes we're seeing is all global warming, it's not. When you have 25% less water evaporating, you get weather pattern changes. And by the way, if you're wondering where the water's going, we're mostly water, right? And when we die, it doesn't go back into the ground as water. That's where it's going. The higher our populations get, the more scarce water is going to get, and we ought to be concerned about that. I'm concerned about it for my grandchildren and the world they're going to grow up in, because a lot of decisions will have to be made on who gets water. How many people realized how scarce water is going to become? Anybody concerned? I am. I'm really concerned about it. And I got to tell you also, desalination, well, you got all these oceans, we'll just desalinate them. Desalination is one of the most destructive things that we've done. I'll just take another 60 seconds and I'm finished. And because when you desalinate, each layer of the ocean has desalination levels, right? Different salinity layers. The lower you go, the more salt you get. So when they first started desalinating, they pulled that top layer off, threw the salt back in the ocean, which made it worse. Our reefs died, our fish died. That's half the world's food source. Every place they built a desalination plant, it's been destructive. Now what they do, in case you haven't wondered what they do with all that salt, it's at the supermarkets. Almost everything you buy today has sea salt. And by the way, sea salt's not healthy for you because it has no iodine in it. You need iodine to operate your thyroid, and that's why a lot of people are on thyroid medicine today. So keep that in mind. Take an iodine supplement if you're eating all that sea salt, but that's where all the sea salt's going. So with that, I will say that is it. I hope the information was useful to some of the people out there. I appreciate you all coming in. Any questions? No? Okay.